Statistics. This is Unit 4, Lesson 8, Anchored Putting, Part 3. Today we're going to be determining statistical significance. So, in a nutshell, statistical significance is like, I'm not saying there's not a difference. I'm saying is there a significant difference. For instance, if you're meeting someone for coffee at 8 a.m., and let's say your friend gets there at 7:59 and you get there at 8:02. Your friend is not upset because you're there in a reasonable amount of time. However, so we don't call that statistically significant, right? However, at school, you are supposed to be at class at 7:15 a.m. when the bell rings, and you get there at 7:16. Then that matters. So it doesn't necessarily matter if 1 minute here and 1 minute there. It's all of the situation. It's not the time that you're like, yes, we're acknowledging it's a difference. Is it an important difference? Or what we call in statistics a statistically significant importance difference. So let's go ahead and turn to Is Anchored Putting Better, Part 3. So go ahead and look at the diagram here, and you can see how one class conducted an experiment. So what did they do to create randomized assignment? So first of all, what they did is they had 20 volunteers, they had random assignment, and they decided to randomly assign them to two groups that were roughly equivalent. Treatment 1 got the long putter, and treatment 2 got the short putter. And then they compared the results. They used random assignment because they needed the groups to be roughly equivalent so that the only change was the length of the putter, and if there was a difference in the results, they could determine it to the length of the putter. So here's the results of the experiment. They put the distance and they said, okay, here's the average distance. And then they subtracted and they got that it was 2.9 centimeters difference is what they did it in. So the average distance from the hole for the shorter putter is 2.9 centimeters more than the average for the longer putter. Do you think the difference between the short and long putter is big enough? Remember what I was talking about the coffee shop and being late for school? We are going to see if it's statistically significant. So I think, this is my guess, that the average distance is less than half the average of the short putter. So we're going to guess that it's going to be statistically significant because it looks like it's double about, which is large enough to have unlikely happen by chance. So what we're going to do is, that's our guess, but we're going to go ahead and put it into this applet here, which we did in class. And if you go to statsmedic.com applets, quantitative variables, multiple groups, we're going to simulate two differences. You're going to scroll down to perform inference and use the inference procedure to simulate the differences of two means, add 50 samples. So we're going to do 50 samples. Basically, that means we're doing the experiment 50 times. So I put my results in, you'll see in here in the app, and then go ahead and hit add 50 samples, and this is approximately what we got. Well, each dot represents one simulation of the experiment and the difference in means calculated from the experiment. So basically what we did is we put all of this data in and we said, okay, what would happen is if I did this by chance, if it just happened by chance. And this is the results we got. And because we only, if you notice our class result that we got was right here at 2.9 centimeters, there's only one that's higher than that, and so 1 divided by the 50 dots is 2%, and so we call anything less than 5% statistically significant, because what we're saying is since this happened by chance, since we simulated these, basically I just threw these numbers in a hat. I threw all of these numbers in a hat, and I said, here, let's see if it's a statistical significance if I just throw the numbers in a hat and I'm able to actually do the results. And the results is this is what I got, by chance. So if it's done by chance all the time, it's like, wow, 50% of the time by chance, it's not statistically significant. But if it only happened by chance 2% of the time, that's pretty significant. So we're saying the putter is longer one is better. The difference in means of 2.9 is unlikely to happen just by chance. And we use, as I said, a less than 5%. That's kind of our rule, unlikely to happen by chance. So if we make an experiment, you can see we have a random assignment. We put them into two groups. We give them each a treatment, and we compare the result. Statistically significant is which means difference of two groups is too large to occur just by chance. And then we perform our simulation. To do a simulation, you enter the data into the app, you simulate it, and you calculate the percent and make the decision. And I will walk you through that in class as well. And this is here. It says fish oil affect blood pressure. So you can see that this already given, this is how you would actually do a randomized experiment. You have 14 men, randomly assign them to two groups, 7 and 7. One group gets the fish oil and one group gets the mixture, and we're going to compare the change in blood pressure. If I calculate the mean reduction for the difference in mean of fish oil minus mixture, you're going to add all of them up, and then you're going to get 6.57. And the mean reduction for groups is that you're going to get negative 1.14 millimeters of this oil that we have, this mercury. So now it wants you to do the simulation. So you're going to put your results in to the simulation, and then you're going to let it do it. And it says now it does it here for you in this answer key. And it says, is this statistically significant? Well, the way you find if it's statistically significant, we got 7.71. So guys, look up here at 7.71 is right about here at the left edge of my screen. And there's only 2 that are bigger than that. So 2 that are more extreme than that. And so there's 2 out of this whole aspect of 100, which is just 2%. And remember, we talked about that 5% considers itself statistically significant. All right. Go to Staplet.com, which it showed you, and this information that I have in here is what I'm going to be putting in. So I go to, as it shows, Staplet.com, Stapplet.com, and I'm going to click this one here, one quantitative variable, multiple groups. So here, and I'm just going to call this distance from the hole, because that's what I'm looking for, distance from the hole. And my name of group 1 is long putter. And my data, I'm just going to list it exactly what it was, where that's this data right here, 2, 3, 0, 2, all that. And you can put commas in between, or you can put spaces. So I'm just going to put spaces, 3, 0, 2, 5, 4, 2, 1, 6, 3. That's right. Distance from the hole. Long putter. Short putter. And I'm going to put the same thing. 2, 8, 10, 9, 6, 5, 6, 5, 0, 6. And then I'm going to begin analysis. And so it graphs them for me, but what I'm wanting to do is to go down here to inference. And so I'm going to simulate the difference of 2 means, and it simulates the distribution of the difference in the sample means when the observations are combined, shuffled, redistributed into groups, matched to the original slide. So basically what it's doing is it's taking all of these numbers to all the ones that we just had, and it's putting them in a hat, shaking them, and then the first 10 that's coming out, it's going to put under the long putter, and the next 10 that's coming out is putting under the short putter, and then it's doing it as many times as we want to do it. So I'm just going to add trials. Oh, I have to have, I'm doing 50, sorry, I want 50 trials. And so there's 50 trials. And this is what it would be if it is completely random. And then what we're going to do is we said, well, in our results, remember, we got 2.9. So I'm going to put, we're interested in what we got in our actual experiment of 2.9. And so, oh, sorry, that says less than. I need greater than 2.9. So we want to see how many are greater than 2.9. And if I count it, you can see that I counted up, and it is 1 out of the 50. So 1 divided by 50 is the 2% that we were talking about in our experiment. So I just wanted to show you how the simulation would work. So that's how it works in your simulation for the golf one, and then you can do it in your homework one. And if you need any other thing, just let me know. And I hope you have a wonderful day.